State Sinema! On the bench today we have a Technics model SA222. The phono input is no-go. Other inputs are A-OK. So let's spin the old think tank. Go from idle to compute. And troubleshoot the techniques with D-Lab's technique. So once again, the fault that's been reported is the phono input is not working. Other inputs are operational.
Not sure why.
So what I'm going to do is inject a signal with my leader audio generator into the phono inputs. Right now I'm injecting a 700 Hertz tone. So I'm going to turn up the volume. We should hear that. And we don't. Well, one thing I noticed, if I touch caps on the board, you can hear it is trying to amplify, but yet the signal is not getting to that input. So you would think, well, maybe it's a bad connection. But remember, this worked one day and failed the other. So we have something else going on. Well, here is the input select board on the Technics. My phono input comes up the shielded cable. We have our left and right, some coupling caps. It makes its way through the circuitry to the input select switches. Now normally you'd be kind of lost. You'd have to poke around and try to trace that signal, but I got lucky and actually found the schematic online, and I believe I have an idea of what happened to this receiver. Let's take a look at the schematic. Okay, here is the phono inputs coming into that board I just showed you. Got little coupling caps, and they make their way through these little transistoroids. It eventually come to this chip, which is a 4559, a little 8-pin chip. So since I've worked on some solid state equipment in the past, the first thing that I always do is check the power supplies. So this has a positive and negative power supply. In this case they're saying about 13 volts here, negative 13 here. So let's go check pins 4 and 8 and make sure the power supply is good before we go any further. Well, there is the chip that we're going to test. Pin 1 is identified by a dot. So 1 through 4, and over here you would have 5 through 8. So you can see the 1 and 8 on the circuit board. So now I'm going to get my meter hooked up. We'll verify those voltages. Alright, I've got the receiver powered up. We're going to buzz out the power supply voltages going to this little 4559 chip that's on the input board. A word of caution, guys, when you're in here with your meter checking voltages on these pins, if you happen to slip and touch two of those pins together, you're going to cause more damage to the receiver. So make sure you have the proper size probe and a steady hand. Okay, here we go. We're going to check pin 4, which should be approximately negative 14 volts. There's negative 14 on the meter. Now let's go to pin 8 and check for positive 14. I've got about 15.1. Alright, so did you guys see what I saw when I was measuring that power supply? Got my plus 15, right? And over here we should have negative 14. Well, look, is that negative 14? That is actually negative 14 millivolts. So let me tell you an old Air Force story. Okay, it's story time here at Solid State Sinema. A little blast from the past. The situation that you just saw was a similar situation that happened to me when I was a quality assurance inspector in the Air Force. So I used to go out and watch teams work on equipment, and they had these big books called Tech Data, and there were steps that needed to be complied with. Okay, so there was a team that was working on a power supply, and one of the indications was for 28 volts DC. So the team grabbed their auto range meter and they were probing in this power supply, and they said, yep, we got our 28 volts. Okay, and they moved on, completed the task, and said that the equipment was serviceable. But in reality, that power supply had a problem, and that meter had auto ranged and it said 28 millivolts. Okay, the guys didn't catch it. I had to sink their ship. So after that, I've always been a big fan of ranging meters. So let's say you wanted to measure 10 volts DC. You would select 0 to 20 volts on your ranging meter, and when you measure it, you're going to see voltage, not auto scale to millivolts, and fool you. Those auto range meters can get you in trouble. Alright, back to the task at hand. We know now that we are missing a power supply on this IC. We had positive 15 volts here, but the negative 13.8, 14, whatever it may be, was actually missing. And it was down into the millivolts. That means pin 4 must be shorted to ground. Let's check that on the receiver and we'll come back to the schematic. Alright, let's buzz out that chip and see if we have a short to ground on pin 4. I've set my meter to the 0 to 600 ohm range. Okay, so it's locked into that range. It's not going to try to move around on us. What you don't want to see is that. That is a direct short. So we know that the positive 15 volts is okay. So that is pin 8. You can see our meter continues to flash, meaning it's seeing an open. Here is pin 4. Look at there. We got 1.3 ohms. So yes, that power supply rail is shorted to ground. Let's go back to the schematic and see if we can figure out what component could cause that. So I know this may be hard to view, but here is pin 4. Pin 4 is going up to these transistors. So obviously if one of those shorted, you got a resistor in line, so it would not be a direct short. But if you follow this path down, you'll see that it comes over here to C426, which is a 100 microfarad cap. The other side of that cap is ground. That is the only path that I see that could possibly short and pull that power supply down. So let's remove C426. Alright, for your reference, here is the IC that we were just probing and found the problem. There is C426. It's a 100 microfarad 16 volt cap. That's on the negative rail, and then this guy has the same value and it's on the positive rail. So let's remove this cap and check it. Well, there it is, C426. Buzz it out with the meter. Look at there. She is shorted. So I went ahead and removed both of those 100 microfarad caps. Here's the other one. So that one's okay, but we're going to change both of them. And let's see if the stereo is repaired. Okay, moment of truth. I've changed out both those caps. We're on phono input. Power it up. There they are. Both channels working on phono input. Good to go. So it looks like I tackled that Technics. Another solid state stereo survivor. D-Lab Electronics. We'll see ya again.